So here we've got quite a simple looking question. We've given the area between the curve and the positive x-axis, and we want to find k. So we sort of start off thinking, okay, so the area, what we're going to do, we're going to integrate that first section between 0 and 3. And then we're going to integrate the second section, and here suddenly we're not sure what the limit is going to be. So it's helpful to think about the graph here, and if you've got a graphical calculator you can sketch it. And it's my rough idea when I had a go at this, is it's going to be something like this. Here's 3, this area is going to be a quarter, but what happens here is this graph actually has an asymptote, so it doesn't cross the x-axis. So this is the way of getting in the fact that this limit is going to be infinity. So the first one, you should recognise that this is a log because x squared differentiates to give 2x. So this is of the form f dash of x over f of x. That's going to be a log, a bit of a clue in the question of what we're trying to find for k. So that one's quite easy to deal with. Now the second one, now we're going to have to think about our limits. So this is going to be the limit, pick a letter, as b tends to infinity of. Now we've got to integrate this. Now this is where there's something quite handy in the formula book. If you have a look through the formula book, you should always consider this for any integration, particularly things with x squareds in the denominator. I can find the one that matches. Okay, and this tells me what it's going to integrate to. So I can now put my numbers in. I've got now, if I look, a squared is 4, so a is 2. So this is going to be, k is still going to be at the front. Okay. And this is going to be a quarter. Right, so then we're going to have to carry on. We can substitute numbers in the first bit, and we can think about what's going to happen with this. So this first bit is quite easy just to substitute in. Okay, now what happens here? So as b tends to infinity, what's actually going to happen to our expression? Well, this ln here is going to end up tending to ln of 1 over 1. So as b gets very large, the plus and minus 2 aren't going to make much effect. So it's going to tend to ln 1. Ln 1 is 0. So that is going to tend, limit as b tends to infinity is going to be 0 for that bit. So that's going to be 0, and then we're going to have to substitute in 3. So we're going to get negative a quarter than a fifth, and that equals a quarter. And all we've got to do now is manipulate the logs. Oh, and there's a k there, multiplied by k, to get k. So this is going to be k. We've got then a half. We've got ln 15 minus ln 6, minus a quarter than a fifth quarter. Now, what's going to be handy here is, you see I've got ln a fifth, so that could be written as ln 5 to the negative 1, and then I can bring that negative 1 in front, so that can be a quarter than 5. And now I can just combine these, so if I take out a quarter in front of as well, I can get 2 than 15 over 6 plus ln 5. And it's just a case of keep going, combining your logs. You can do some fewer steps. Oops, if you are confident working with logs. So we can now cancel out the quarter on both sides. So k times, this is going to be ln 15 over 6 squared times 5 equals 1, which when you actually work it out, it's going to give us k is 1 over ln, and that's 125 over 4, which looks pretty horrible, but it is true that a is 125 over 4. Don't be put off if some of your answers aren't necessarily integers. It doesn't say it's an integer, it just says it's a constant.